Hi everyone. Minor hiccup. I don't know, something happened. My OBS crashed. So yeah, welcome to the channel. Welcome to the channel of AI Coding with K. It's your host here, Kshitij Agarwal. Quick intro about me. I'm an engineering manager and an engineering consultant with 19 years of experience in industry with building products for mobile and AI. And welcome to the episode 2 of our course on learning how to use AI effectively as a junior developer. Today we are going to be talking about task framing for AI coding. Just a short recap on what we did uh, in our last session. So we basically talked about how we should frame our task brief to give to the AI, which has a lot more context, which has a lot more boundary, which has a lot more information, and which is not vague. This is the important bit. It is not supposed to be vague, but it has to be concrete. It has to contain all the required information for what the task is going to be about. Okay. And today we are going to kind of expand on it a little bit. And let me move to our slides. And cool. So today's episode is mostly going to be about task framing for AI coding, and which is going to help you turn a vague work into an AI ready task brief. Okay. So um, like I mentioned in the previous episode, we talked about the workflow, what things you need to kind of take care of in terms of when you are using AI to build your systems. Why is it important? Why we need workflows instead of just giving prompts? And this week on episode 2, we are going to talk about the AI, the task brief that we are going to build to give more concrete information to the AI. Okay, so it is the term that I'm going to be using today is called task framing. Okay, and task framing, what it basically means is that you are turning vague requests into very clear, bounded, AI ready task briefs. Okay, the idea is that you're not going to type like build my feature X. You're going to tell it that this is the feature that I'm trying to build. Okay, these are the pieces that I want to implement, and these are the things that I don't want you to touch. Okay, and then you add even further detail of not just build me a feature, but rather these are the steps that you need to follow, these are the things that you need to add to build the said feature. So this is what task framing is. You are trying to frame a task out from a very vague request. Okay, this is not really a PRD of sorts. It's not a documentation that you build in a normal service industry kind of a deal, and it is not, and it's not even an implementation plan, because implementation plans are still a step above of what a task brief is about. The task brief is a bit more constrained. It is more about what you want the AI to do right now in one step, rather than you're trying to create a full-blown implementation plans. Okay, so the idea is it doesn't need to be vague. It has to be very clear. It has to be bounded. It has to be constrained, and it has to be very to the point, because otherwise, like we mentioned earlier as well, AI tends to hallucinate. AI tends to assume if the information is not given to it. So the LLMs will try to assume that, okay, probably the user is asking for this, and then it will eagerly try to work on something that you probably didn't want it to do. Okay, so we'll talk about it as we move forward. So now again, like I was just talking about, AI is going to do assumptions. So why not let AI figure it out? Because very important thing is that it doesn't know your product intent. You as a developer know exactly what you want to build, where it needs to be, who is the target audience, what problem you're trying to solve. And because only you know that, you cannot let AI assume these things. You cannot let AI figure it out for you. You have to share this information with AI of what you are trying to build, why you are trying to build it, where it needs to go, who is the target audience, what are some of the more detailed information that you need to share. Okay. Again, this like I mentioned here, the second point is it doesn't know the architecture boundaries. Okay, so AI can analyze your product, analyze your existing code base, but it is you as a developer who has to build this architectural boundaries of where you want the change to happen, whether it is just a UI change, whether it is just a backend change, or whether it is a middleware change. So these are the things that you need to specify while you are working on building this task brief. And again, why you can't let AI figure it out for you. Okay, you are working in a team, so you have to, AI doesn't really know what the other team members are doing, what exactly is the coverage of the task that is being distributed within the team members. So again, if you let AI run with the vague request, it will try to do things that probably which are already assigned to some of your colleagues, some of your team members. So again, it is you who has to create those boundaries for that specific task. Okay, and again, the last point which I've actually mentioned in the beginning, it is going to invent decisions, it is going to make assumptions, and you don't want it to do that, because otherwise the product that you're building is not going to be up to the mark on what the desired outcome should be. Okay, so now what is happening here? If I take a step back, I really want to bring home a point where what is AI doing? Okay, AI is basically at this point changing your role, okay, as a person who is working on a product. Okay, you are not a coder anymore. So there is a coder mode for in the life of every developer. There's a coder mode and then there is a developer mode. So I just want to bring that home, this concept of what is a coder and what is a developer, because you need, if you have this context of what a coder is and what a developer is, then you would better understand where do you sit. Okay, a coder is simply a person who's converting a set list of instructions, written instructions, into code. You are given a file, you are given a method, and you are given, okay, these are the changes that need to be done, and you're making those changes. So that is a coder. Okay, and every developer has to code. So a developer is a coder, but a coder is not necessarily a developer. Okay, what a developer does is more than what a coder does. Coder is just converting instructions into a code. It is just typing on in your IDE and just converting the idea into exact code. But what a developer is basically doing is, developer is focusing on what should be built, where does it sit, and how do you verify the changes that are being done. So that is very different from a coder. Coder is just converting instructions. Developer is trying to figure out these instructions, trying to figure out this is what needs to be built, this is where it needs to go, this is the file, this is the method, these are the list of methods that I need to change, these are the list of files that need updating, this is the architectural paradigm, architectural flow that I have to follow, and these are the tests that I will have to write, or these are the test suite that I will have to update in order to verify the changes that I'm making. So there is a huge difference between a coder and a developer. And now with the advent of AI is the coder. LLM is coding for you, and you are now a developer. You are going to focus on what needs to be built, where it needs to be built, and how to test it. Okay, so keeping that in mind, you now have to figure out how the task is going to be framed. You are the developer, you have to have the bigger picture of what needs to be built. Okay, and and you just give those instructions to the coder, which is the AI slash LLM in this case, and then you just pass on these instructions and AI will do those code updates. Okay, so now as a developer, so one thing that you need to keep in mind is that it is not just a matter of correctness. Okay, so there is a term that we use in development, which is, or rather a phrase that we call is correctness versus effectiveness. Okay, correctness is what AI does when you give it vague requests. You say, build me my task tracking app. Okay, it is going to build it, no doubt about it. It is going to build something in a very short span of time, which will probably work for the most part. That is what correctness, that comes into the category of correctness. Correctness is you have a request, you build something and it is working. That's fine. But effectiveness, correctness versus effectiveness. Effectiveness means you build what you wanted to build. It is working as you intended to work. It is robust, that it is not breaking where it should, where it really matters. It has a proper product fit. You have in mind, while the effectiveness is determined by who is going to be the user, what is the feature is going to be about, whether it is working or not. So in effectiveness, correctness is just the baseline. You start from correctness, you build something, it is working, that's great. But effectiveness is, did I intend to build it exactly what I wanted to build? Is it going to solve the problem that I wanted to solve? And whether it is going to go to the it is going to matter to the target audience that I'm building for. Okay, so that is what effectiveness is. And effectiveness means, the last point in the bullet point, effectiveness means the right change in the right place with the right checks. Okay, so a bit of a conceptual stuff I'm talking about, but it is more, all of this is very fundamental at this point. What I am going to teach, what my aim is in teaching with all of my sessions with this channel, AI Coding with K, is about helping you become an effective developer, a better developer using AI. Okay, so you don't use AI but just by giving prompts. You need to be effective about what you are building. You are not a coder now, you are a developer now. You need to create, you can't give vague prompts, you need to create proper task briefs. Okay, you need to think about architecture, you need to think about the product, you need to think about the user, you need to think about the test cases and the verification of what you have just built. So these are the changes and these are the things that I'm trying to teach here. It might sound a very conceptual, very, how do you call it? Very theoretical, but still it is very important, because if you understand these things, this is something that you can carry with you in any field. It can be a mobile app, it can be a web app, you can be a backend developer, you can be a front-end developer, you can be in data analytics, data science, or wherever you are working. The idea is that all these things are very conceptual, very core to how we are starting to work with AI now and how things are going to be in the future. Okay, so let's move ahead. And so, like I was talking about correctness versus effectiveness. Correctness is just whether the code is working or not. That is the non-negotiable, that is the baseline. Effectiveness, does it solve the problem that I was trying? Whether it fits the current set of systems, whether it has stayed within the scope that we had defined as a developer, as a product builder, as a team member who was working in a team with anywhere from a small team from a large team, and whether whatever you are building is verifiable. Okay, so now you are not a coder, you are a developer, you are a task framer. What is your job now? You need to brainstorm what the request is. Okay, so you need to convert that vague request to an actual concrete request. So you need to brainstorm about it. You need to evaluate what are the possible solutions in order to build, in order to perform that task. So you need to figure out what are the alternate options, interpretations, implementations that you can follow in order to do it. Okay, you need to analyze the current existing behavior and constraints, whether it is architecture, whether it is functional, whether it is a user request, whether it is a backend restriction that this is the API framework, then you have to follow this. The constraints can be anything. So it is your job to figure out those constraints and add them as part of the task brief. Okay, and very important part of it is that you need to break the task into smaller subtasks if required. You cannot just say that build me an app. You can probably start off with build me a login screen or build me a home screen of my task tracking app. Okay, so you don't give a vague request to build a full-blown product. You break it down into smaller tasks, and then you figure out, okay, what is the priority of which task it needs to come before which, and then you need to focus on that subtask first. So that is your job as a task framer. Okay, and last but not the least, boundaries and very important, examples. If you have an existing code base, you tell the task that, okay, follow the architecture guideline which this file is already following or this method is already following. Okay, these kind of examples you can give. You can tell it to look at the existing test suite, okay, to follow the instructions and replicate that for a new feature, for example. So it's not necessary that you will need all of this all the time, but this is a major list of things that you need to take care of while you are working on any new task. Okay, so what is a bad request? Example, add a due date to my tasks. So in the previous episode, we were trying to build a task management app for the students to follow their coursework. Okay, so a very vague request that people might add is add due date to task. This is very vague. It doesn't have any details. What are the boundaries? What are the actual requirements? What exactly needs to be done? None of that is here. Okay, so what this task does not say, it doesn't know where the due date label needs to appear. It doesn't say which due date labels are needed, maybe overdue or maybe upcoming or whatever. Okay, it doesn't tell the AI what happens to completed tasks. It doesn't know how to react to sorting, reminders or calendar syncs, and it doesn't know how to deal with time zones, whether it is just local time. So this is just an example of a due date for a task. Okay, for a due date for a task, there are bunch of things that are required which are not there in the previous prompt. Okay, so this is an example, and now we are going to talk about how a task should look like. So this is a framework that you can follow, you can carry it with you anywhere, any task, any field, any kind of product, any technology. What the task is, okay, so an anatomy of a complete brief, task brief, it looks like a concrete task title. Okay, what who the user is, what is the existing behavior, what is the desired behavior, what are the boundaries, what are the things that you should not be focusing on. You have to tell AI things that it should not be focusing on. For example, if I'm focusing on adding a task to the adding a due date to a task, okay, then it should not be figuring out how does the calendar sync happen. No, it should focus on just that one thing. How it will behave with calendar sync is an separate task that will come separately after the current feature of adding a due date to a task is implemented. So that's where the subtasking or breaking down of the task comes in. So right now you are purely focused on adding a due date, so you have to tell it, don't go into this, don't try to deviate from what we are trying to build. Okay, and you have to if you have any examples of any ambiguity, you can give that, and you have to, if you have any test suite or if you have any checks or recommended architecture that you wanted to give, you can give that. Okay, this is a framework that you can carry again into any field. So a filled task, what it will look like? Who is the user? What is the existing behavior? What is the desired behavior? User is a student who is working on a study sprint task list app. Current behavior is there is a title and there is a state whether it is done or not. The desired behavior is you need to add a due date, whether a task is due or not. Okay, so and the step above from what we just discussed are the labels, exact requirements that you want to add. What are the labels today, upcoming, due date? What are the boundaries? What are the non-goals? So in this case, we are not focusing on the sorting or the reminders or the calendar sync. So we are going to tell it that these are the non-goals, and then the checks are whether yesterday, today, tomorrow, what are the test cases. So if I have a task which is due yesterday, how it will look, whether it is a task in the future, how it will look, whether it is past 7 days due, what will be the label in that case. Okay, so all this comes into a test case. So again, bad prompt, add due date to task. A good framed prompt is task. What is the task is add a due date label for each task. Labels, you specify the labels, you have boundaries, you have non-goals, and then you have a requirement of inspect files and check before code. Okay, so this is a proper framed task prompt that you give. It has everything that an LLM needs, including things not to touch, including things that it should not be doing. Okay, so this is a framed complete task that we have. So a wait prompt, what it will give you, it will jump files, it will first it will waste time try to figure out where it needs to make the changes. It will try to invent places of where things should happen. Okay, it will waste time trying to figure out, and more importantly, not just time, it is going to waste tokens in trying to figure these things out, trying to make assumptions, trying to figure out the places where the changes needs to be made. All of this consumes tokens. Okay, and actually an idea that I received from one of the community members is to talk more about how do you optimize your tokens. So that was a kind of a very umbrella question, but I am trying to see if how I can create a very small session on working with tokens, optimizing tokens, and really focusing on building more with consuming less tokens, because tokens, as you know, are becoming expensive. Claude, ChatGPT, Gemini, all of them have drastically increased their token costs. So that is something that we should all know, and I will do a session about it as well. So coming back to this, so the expected output of what a vague prompt will give you is code jumping, file jumping, inventing decisions, unscoped changes, which means it is going to make changes to files or methods where it didn't really had any business to. And sometimes actually Codex does this a lot. So I'll share those experiences as well down the line. And it may or may not run your test suite. Okay, but it is up to the LLM's decision whether it decided to run the test suite or not. What you get from a proper framed prompt is what change you want to be done, exactly what all things are required for that change, where that change needs to happen, what that change should not be updating, touching, or modifying. Okay, what are the tests that it need to run, and what are the verification checks that it need to do. Okay, so you get all of this if you spend a little bit of extra time framing a prompt instead of sending vague requests to the LLM. Okay, what is a task framing template? So I've split it into two parts. One is the context and one is the control. Okay, so the context side is the task, obviously, what needs to be done, who is the user, what is the current behavior, and what is the desired behavior. This will give LLM the proper context of what it needs to work on. Okay, what is exactly the pieces that are required to be modified. The control side is the boundaries or the guidelines or the guardrails that you will be adding. Which files to change, which files not to change, which portions of the product you don't need it to touch, what are the modules that it should not be touching because maybe your colleague is working on them. Okay, what are the tests it needs to run, and what are the examples, if any, you have in your existing code base that the AI should follow as a template. Okay, so these all things come from the control side of the task template. So you have a context and you have a control. You tell what to do and you tell it where it needs to do it and what not to do. Okay, so these are the two things that are basically part of this template. So this I think this is the my last part of what I wanted to touch, and the prompt, what you are basically focusing on now is basically the quality of the prompt that you are giving to the AI. Now we are not giving vague AI tasks anymore. I don't want anybody who's watching, I don't want you to send vague prompts to the AI from now on. I want you to be very specific, tell it exactly what you need, so that you get a much better structured result of what you actually were looking for from the AI or the LLM or the agent. Okay, these are synonyms at this point, so I could change them interchangeably. So the idea is that you as a developer still hold all the judgment. You tell exactly what you want. Okay, you create the boundaries for the AI LLM to work and not move outside of it, okay? And you basically control what needs to be built and what it should not be touching. So again, the same thing comes again and again that I'm talking about it. Be exact of what to work on, what to build, what to update, and be aware of what not to update and tell it to the AI. Okay, so this is done. This is part of the whole task framing thing that I wanted to talk about. In the next episode, we will be talking about building task context. Okay, I will be talking about how do you build a context for the AI, for the LLM to perform a specific task. And yeah, thank you so much for watching. And if you like the sessions that I'm doing, if you're not subscribed, if you can subscribe, that would be really helpful. You can join my Discord. The links are in the descriptions of the video below. And yeah, if you have any questions, you can comment in the YouTube section, or you can join my Discord to talk to me directly. And if you have any queries you want to clarify, I will also be holding office hours on my Discord where I will go live, and then you can ask your questions with me directly. And if you want me to answer your questions, I can do that on another live stream as well. So thank you so much, everybody. Thank you so much for watching, and hope you enjoyed this. Thank you for being here with me, Kshitij Agarwal. And yeah, have a nice night. Good night.